Good evening all. Am I audible? Sri Krishna, good evening. Ananta Streaker, good evening. Tejas, good evening. Varsha Reddy, good evening. Okay. So today's topic is STM32 Nucleo timer input capture mode with frequency measurement example. So in this session, we will discuss how to configure timer module in input capture mode to measure the frequency of an input signal, and we will program our STM32 Nucleo in STM32 ID and build a frequency counter whereby like one input capture channel will be enabled to capture an external signal on the rising edge. Okay, so let's get into the topic. STM32 Nucleo timer. See, actually STM32 F446 already comes with 17 timers. Okay, so they act as a clock and are used to keep track of time based events. Okay, so the timer module can work in different configurations such as timer mode, counter mode, pulse width modulation mode, output compare mode, etc. So this guide focuses on configuring the timer module in input capture mode. So when configuring the STM32 Nucleo timer module in input capture mode, an internal source clocks the timer module, which is the input capture channel pin. So when a particular event occur on the input capture channel pin, its current value is captured and saved to the input capture register. That's a particular register for this timer CCR register. Okay, so this set the corresponding CCXIF flag and trigger the interrupt or DMA if it was configured. So the capture or compare registers are responsible for securing the counter value after a transition detection occurs by the particular sign. Okay, so as you may see in this circuit, the capture channel consists of a capture register with a shadow register. So an input stage consisting of a digital filter, a multiplexer and as well as prescaler for capturing. And then like output stage consisting of output control and a comparator. Okay, so your timer configured in an input capture mode is helpful in many applications where signal measurement and like external event timings are required. See, frequency measurement with STM32 Nucleo pill. So we will set up a code in which channel 1 that will be set up as an input capture direct mode for all rising edges. Okay, so the rising edge of any digital signal is an edge where the transition of the signal occurs from an active low level to an active high level, and furthermore the timer period is the time between two consecutive rising edges or falling edges. Okay, so the external signal will be captured to measure frequency that will used to do build a frequency counter. So to calculate the frequency values, we will first read from the CCR1 register and obtain the values on the first and second edge, that which will be T1 and T2 respectively, as the period of the input signal that will be subtracted from T2 from T1. Therefore, frequency which is 1 by the period can be obtained from this value, right? So before getting into the project setup, let me tell this important thing, which is you can convert this masterclass into 1 month internship on STM32. So the actual amount of this 1 month internship is for 1999, but there is a discount amount which is available for you, which is only for 799. So use this registration link to get your 1 month internship on STM32. So what you will get in this 1 month internship? 30 days of live plus 30 days of recorded session, 30 days of presentations for download, 5 project source code for download, 1 month internship certificate, participation certificate, 90 days of access to the courses, 4 hackathon live sessions, and you can join to the community group. And also there is a 3-in-1 bundle course is available for you. So among these 4 courses you can choose any 2 by your own, but STM32 is the default one, you can't change that, right? So the actual amount of this 3-in-1 bundle course is for 3000 rupees, but there is a discount amount which is available for you, which is only for 1199. So use this registration link to get your 3-in-1 bundle course. And what you will get in this 3-in-1 bundle course? 90 days of live plus 90 days of recorded session, 90 days of presentations for download, and 10 project source code for download, 3 internship certificate, 1 year validity to the courses, and hackathon live session, and you can join to the community group and you will get your assignments and mock test. And while making your payment, don't forget to add the courses that you want, because you have to mention the course properly, then only you can able to get those particular course in your LMS portal, right? Okay. So now let's get back to the topic. Okay. So here I'm just going to write the program and I'm just going to show you how to write all those programs. So this is the hardware setup. You just need 2 things. One is STM32 Nucleo board, and you can take whatever the board you want. Here I'm using this particular board, and Ardino board. You just need only 2 jumper wire. You need to connect the ground to the STM32 board to the Ardino board, and you need to connect the pulse width modulation pin. You can take whatever the pulse width modulation pin you want. Here I am taking 6th pin, and you have to connect the 6th pin with the analog pin over here, PA0 or from Ardino A0. You can connect any those 2, right? So you just need to connect these 2 things. One is ground, you have to make a common ground, and you need to connect this analog pin to this pulse width modulation pin. This is the hardware setup. So after writing all your program, you just need these 2 things, and you just need to upload these 2 program into Ardino IDE. You need to write Ardino IDE program in Ardino IDE, and you need to write STM program in STM Cube IDE. You need to upload the program separately and then make the connection. You will get the output. Now let me show you how to create a project. For that, go to your STM32 Cube IDE. Let me create a new project. Okay, so let me select STM32 F446RED6. Sorry. Okay, so here first step what you need to do is that go to timer, select timer 2, and then clock source you have to select internal clock, and then channel, input capture direct mode, and you can scroll down and you can check for the settings. Okay, so parameter settings, capture mode has to be in up, and the counter period has to be set with 65535. Hit enter and then make sure that auto reload is enabled, and then polarity selection, this has to be in rising edge, and then go for NVIC setting, enable this interrupt, and then go for connectivity, go for USR2, make sure that you have selected the asynchronous. You can also view the parameter settings of the UART, including your baud rate, word length, parity, everything. Okay, so now you can go for your system core, go to RCC, and here you have to enable this HSC, crystal ceramic resonator, in from high speed clock feature, and then go to clock configuration. Here I am going to select HSC PLL clock, and I am going to change this to 8 megahertz, and over here I am changing this to 72. I am going to hit enter, and I am going to save this program to generate code. Okay, so now after this main, I am going to include one more library, which is nothing but standard input output.h library. Okay, and then I am going to define some macros over here, where private, define private macros. So over here I am going to define some macros. So define ideal, I am going to define ideal as 0. So this represents the ideal state of the system, and then I am going to define done, which is 1. So this represents a state where some process has completed. Okay, and then I am going to define FCLK, frequency clock, which is 7 to UL. Okay, so 6 zeros, 1 2 3 4 5 6. I have given one more 0. Okay, so this represents the clock frequency of 72 million hertz, which is nothing but 72 megahertz, and UL is nothing but unsigned long. Okay, and after that, okay, now let's define some variables. I am going to take the type volatile, unsigned integer 8 underscore t, and I am going to give a variable name like state. I am going to initialize this with id. So just to store the current state of the system, see, the volatile keyword tells the compiler that these variables can be modified by the external source, such as interrupt service routine. Okay, so the compiler should not optimize code involving these variables. Okay, so ensuring the program always reads the actual value. Again, I am going to take volatile type unsigned integer 8 underscore t. Now I am going to give a name like a message. Here I am going to pass 35, and here I am going to use a set bracket, and inside I am going to initialize this with null character. Okay, and then again I am going to take volatile unsigned integer 32 underscore t. I am going to give t1. I am going to initialize this with 0. Again volatile unsigned integer 32 underscore t. Now I am going to take t2, and I am going to initialize this with 0. So to store the time when the event occurs, okay, again I am going to take volatile type unsigned integer 32 underscore t. Now I am going to create a variable called ticks, and I am going to initialize this with 0 to store the difference between t2 and t1. Okay, and now I am going to take volatile unsigned integer 16 underscore t. I am going to give like timer 2 underscore OBC. So what is OBC? Overflow count. I am going to initialize this with 0. to store the overflow count of timer 2. And at last, volatile unsigned integer 32 underscore t frequency. I'm going to initialize this with 0 to store the calculated frequency of the signal that is being measured. Okay, so now we can go for integer main function. Scroll down. Here I'm going to use one hall function. So hall timer base start IT. So inside I'm going to pass address of h timer 2 and then hall timer IC start IT. So inside I'm going to pass address symbols of h timer 2 and now timer channel underscore 1. Okay, and then inside, while there is nothing we can do with, scroll down all the way, you may find out the function like static void mx gpio initialization. So after this function, that's the thing called user code begin for. Here I am going to create one function. So void hall timer IC capture callback function. So instead I'm going to pass timer handle type def with pointer and then I'm going to give h timer. Okay, so this function is a callback that executed whenever a time capture event occurs. Okay, so inside I'm going to create one if condition. I'm going to check whether state which is equal to in ideal state or what. So inside what I'm going to do is that T1 which is equal to timer 2 and here I'm going to use that register CCR1 register. So the current value of timer 2's capture or compare register is stored in T1. So this represents the time of the first edge and then timer 2 underscore OBC overflow count. I'm going to initialize this with 0. Okay, so now the overflow counter is reset to 0 as the measurement is starting new. Now I'm going to initialize state to done. Okay, so this state is changed to done, indicating that the first capture has been completed and the program is now waiting for the next edge. Okay, so after this I am going to create else if condition. Inside I am going to check state is done. So inside I am going to pass few lines. So T2, now this is for T2 timer and I am going to use CCR1 register. Okay, and after this another condition, if timer 2 is greater than timer 1, if this condition is true, in the sense inside I am going to do one calculation. So ticks which is equal to C T2 plus timer 2 overflow count. I am going to multiply this with 65536. Okay, and after this minus T1. Okay, just a minute. Okay, and after this I am going to minus this whole value with T1. So this calculates the number of ticks between T1 and T2, accounting for any timer overflows that might have occurred. So here 65536 is the maximum count value of a 16-bit timer before it overflows. Okay, now frequency which is equal to unsigned integer 32 underscore T and then F clock, frequency clock, which is divided by ticks. Okay, so the frequency of the signal is calculated by dividing the clock frequency by the number of ticks. So this gives the signal's frequency in hertz. Now I am going to create one more condition, which is I am going to check if frequency is not equal to 0. Okay, if this condition is true, in the sense I want to using sprintf function, instead I am going to pass message frequency, which is equal to percentage long unsigned, and then I am going to mention it in hertz. Let's go for new line, new row, and then I am going to give that frequency, and then I am going to use whole library UART transmit address of HUART to message size of, I need to pass that message, and after this 100. Okay, so that's it. Now after this again I am going to mention that state to ideal. So finally the state is reset to ideal to prepare for the next measurement cycle. And after this I want to add one more function, which is called whole timer period elapsed callback. So instead I am going to pass timer handle type def with pointer h timer. Okay, so inside I want to give, see, this function is a callback that gets executed whenever the timer overflows. So meaning is that it has reached its maximum count and rolled over to 0. So instead I am going to give like timer 2 underscore OVC. I am going to increment this timer overflow count. So each time the timer overflows, the overflow counter, timer 2 overflow counter is incremented. So this counter tracks how many times the timer has overflowed between the two capture events, which is T1 and T2. Okay, so this is the STM32 program. Let me save this and let me build. Do we have any error or not? Let's check. We have error among where over here. So T2 it is equal to, yeah, I forgot to give the timer 2. Let me save this and let me check. Again one error. Where it is? Over here we are having error. Inside, okay. So whole timer IC started. Timer 1, we didn't take timer 1, we take timer 2, right? Okay. Okay, so now 0 error. Warning, it may have some warning, but no issues. Okay, fine. So now we can go for Ardino programming. Okay, so here, okay. So we have written program for STM32. Now we can write program for Ardino. Just a simple program. Here you just need to give like the data type, and you can take pulse width modulation pin. I'm going to take pin number 6. And inside setup you need to mention its mode and thing. So PWM pin, I'm going to set this as output pin, and I'm going to use analog write function. So instead I need to pass pulse width modulation pin, and I need to give the thing 127. This is the mid value. So analog read values go from 0 to 1023. Here we are using analog write. So analog write values go from 0 to 255. I just give the in between value. So there is nothing we can do with void loop. This is the program. Let me save. No, we don't. I don't want to save. So this is the Ardino program, and this is the STM32 program. You just need to have two boards. One is Ardino and one is STM32. So you have to write the program, and you have to fire your STM32 program in your STM32 board, and you have to upload your Ardino program from Ardino IDE to the program. You already know how to boot program into your microcontroller, right? So you have to make it a common ground, and you have to connect. You have to take pin number 6 from Ardino Uno, and you have to connect that particular pin to the PA0 or A0 pin of STM32. So this is how you will get the output in the console tab. Okay, so I hope you understand. Again, let me come with an internship. Okay, just a minute. So you can convert this masterclass into 1 month internship on STM32. So the actual amount of this 1 month internship on STM32 is for 1,999, but there is a discount amount which is available for you, which is only for 799. So this is the registration link to register your 1 month internship on STM32. So what you will get in this 1 month internship? 30 days of live session plus 30 days of recorded session, 30 days of presentations for download, 5 project source codes for download, 1 month internship certificate, participation certificate, 90 days of access to the courses, 4 hackathon live sessions, and you can join to the community group. And also there is a 3-in-1 bundle courses available for you. So in the lineup, you can choose any 2 courses from these 4 courses. STM32 is the default one, you can't change that. So the actual amount of this 3-in-1 bundle course is for 3,000 rupees, but there is a discount amount which is available for you, which is only for 1199. So to register 3-in-1 bundle course, you can go for this registration link. And what you will get in this 3-in-1 bundle course? 90 days of live session plus 90 days of recorded session, 90 days of presentations for download, 10 project source code for download, 3 internship certificate, 1 year validity to the courses, hackathon live session, and you can join to the community group, and as well as you will get your assignments and mock test. So while making your payment, don't forget to add the courses that you want in the domain tab. So this is all about today's session. The attendance link is provided in the chat box. Go and mark your attendance. Thank you all. Have a very great day.